So, hello, good afternoon, everybody. Welcome to our breakout session where we talk about key factors to consider when selecting an electric motor. So, first of all, I want to introduce the speakers of this breakout session. Welcome to my colleague Bruno Joffre. He's our market manager for mobile electrification. Bruno has led various electrification market development initiatives in Europe over the last 12 years, and he also successfully collaborated on many electrification projects with various customers. And he also launched the first Parker e-pump standard catalog combining hydraulic pumps and electric motors. So Bruno can really be considered to be a subject matter expert in PMAC motors and an authority in mobile applications. Then let me also introduce myself. My name is Frank Durbin. I am the division marketing manager for Parker's electric motion and pneumatics division here in Europe. During my career, I was leading the market launch of various motors and inverters dedicated to mobile electrification. And I have more than 20 years of experience in electrification technologies applied into industrial as well as mobile applications. So, what's the agenda for our breakout session? We will start with a quick introduction, and then we are going to talk about the technical criteria to be considered when choosing the right motor for your application, scalability, finding the right motor that is tailored around your specific application, efficiency and performance, making sure that you get the most out of your batteries, reliability. Your machines have a reputation in the market, so reliability of the critical components like the motor is also crucial. Then sizing, because sizing and selection the right motor is a complex task. We will also share our thoughts on noise emissions. And then we're going to talk about the topic of electro-hydraulic pumps, because there is criteria to be considered for the motor itself, but it is equally important to look at the application, especially when you apply the motor to control a hydraulic pump. And then we will talk about components versus systems and why you should think about your preferred level of integration and make that part of your overall choice. And then lastly, we will finish with our conclusions and open for a Q&A. So that's it. I will hand over to my colleague Bruno to get us started with the introduction.
Hello, everybody. So speaking about the key factors to consider when selecting an electric motor, I would say that electrification can be implemented at different levels on the existing types of vehicle we are using at the moment. Traction is for sure something common to all vehicles, but it requires a large amount of energy that needs to be stored in an as compact as possible reservoir we are still looking for to get an interesting range. Work function, by the way, are the best way to start electrification trip. In this case, the internal combustion engine, or ICE, is to be replaced by an electric motor and its associated inverter to pass from the traditional power takeoff, or PTO, to the ePTO, electric power takeoff. But what are the advantages of such a solution? In a world where we are more and more confronted with low emission zones, it allows to decouple the IC engine from the work function to make it work without any emission and only when requested. The electric motor will bring a solution far more efficient, quite dynamic, compact, and less noisy than the IC engine. Adding on request the inverter, the controller, the cooling system contained in a bespoke frame makes it easy to integrate in the vehicle, as we will see a little bit later. So we are going to review the major customer value of the global vehicle motor, the GVM, we were able to propose for such applications. At first, we've got 3 different sizes as a scalability advantage: 142, 210, and 310 square frame millimeters. By the way, we've got also the same traction interface and pump interface available on each size, up to 6 lengths per size are available. It means that we are able to provide the right torque level depending on the adjusted lamination stack length. That makes it really very scalable and that is able to take the less space as possible, in the vehicle. This kind of motor is available for low and high voltage. That can represent an interest, speaking about the cost of the inverter at least. And we've got multiple windings available. The windings are, in fact, the ratio in between the battery voltage and the rotation speed of the motor. So we can speak about another advantage, that is the efficiency. The efficiency will define, in fact, the range of the vehicle that will be equipped with the motor for a given electric energy that will be stored in the battery. As you can see on the different pictures on the bottom of the page, we've got a wide range of torque and speed that is specific to the GVM motor. Very large, the torque is vertical, the speed is horizontal, and we've got really a variable speed possibility on this side to drive really the pump in a good way, to be able to pass from the variable displacement to the fixed displacement. That can be considered as a benefit, speaking about the efficiency either. And you can see the two pictures, we've got quite the same level as generator or motor. And that's really very important to recover the energy, as we've seen previously during the different explanations that have been given. So the next topic is the performance. So that's really very important. We've got, with this kind of motor, a very high power density, and it's given by the patented cooling system that enables us to include more current inside the same size of motor than competitors, as you can see on the picture on the top right. We can, thanks to the permanent magnet AC motor technology, get the full torque at low speed. So that's very important to start a vehicle running or whatever. We've got also, thanks to the capacity of the motor, low inertia and high dynamic, by the way. And this technology allows also the flux weakening, which is quite useful to reduce as much as possible the size of the inverter. Looking after the next topic, that is the reliability, it's something very important, because for sure, when you replace an IC engine by an electric motor, you need to have at least the same, but even a higher reliability. And that's what we did, really performing many validation tests. As you can see on the top right, we've made a performance test in accordance with the SAE J1455, such as dust, sand, gravel bombardment, humidity, salt spray, immersion, operating temperature in extreme conditions, crash, shock, and vibration tests. On top of that, you can see in the middle of this picture that we've made over 135 millions of road miles on a hybrid vehicle. So that shows really the reliability of this motor. We've got a high ingress protection level. This is an IP67 motor, and it becomes an IP6K9K, to be kosher washed, when it's assembled together with a pump or with a gearbox. It's equipped with ceramic ball bearings to be able to reach a high rotation speed and to avoid transient current effects. By the way, one of our major customers has claimed that the motors he has tested, the GVM was the best of the lot. So that's something very important. And the major customer value is the long lifetime we can provide, the reduced downtime, and less maintenance. For sure, that's an important topic. The next customer value we can bring is really to provide a kind of bespoke system, very deeply calculated, and it's based on a specific software we have built on our side. And by the way, you can see on the right the torque and the speed value. So we can make calculation based on torque and speed requirements for sure, to find the really. I've spoken about the lamination stack length, the windings, etc. We can also make some calculation based on the pressure and flow. It means we are considering an additional pump on top of the motor, and we will be able, in this case, through our wide knowledge about electro-hydraulic pumps, to make precise calculation about the pump, the motor, and the inverter. You can see on the bottom left, the picture showing the type of software we are using to do so. So, speaking about the next challenge is, I think, the noise emission. It's the next pollution, in fact, we will have to fight against after the particles and the fumes. And we've got some potential ways through electrification to reduce this kind of noise from a motor perspective. At first, we can replace the IC engine by an electric motor. It's quite noiseless. We can place pumps into the oil tank to lower the pump noise. That's something important. And the last but not the least, we can immerse the electric motor and the pump, as you can see on the picture below, inside the oil tank. So for sure, it's not feasible with all the type of motor because of the rotor frame, but that's something we can look after at the moment.
All right, thank you, Bruno. So now that we gained some insight on the important criteria for the motor itself, let's take a closer look at the hydraulic work function ecosystem. Whenever you apply an electric motor to control a hydraulic pump, you have to connect the two components. So a once popular method, which you see on the left-hand side here, was to connect both components with a coupling, with the mounting flanges connected to a bell housing. So this holds a few significant disadvantages. Obviously, this method requires additional components that need to be purchased, and then you also have to consider the additional installation work, both of which are driving cost. On top of this, the coupling is also adding inertia to the system, so the dynamic response to speed changes is limited. Therefore, a more popular method these days is to use a spline connection, as you can see on the right-hand side here. So here the motor utilizes a female spline, while the pump has a male shaft that directly plugs into the motor's female shaft. So there's a couple of advantages with that. It is a direct connection, so obviously you do not need any additional external components like the coupling and the bell housing. It also reduces the overall length of the total system and the footprint, the weight, but also the cost. And also it promotes tighter control because this solution has zero backlash. However, please pay attention. So a female to male spline connection consists of a direct metal-to-metal contact between the spline teeth. So proper care must be taken in the lubrication of the splines to prevent threading corrosion and assure a long shaft life. Otherwise, the connection can break, and that can lead to costly repair of the motor and also unplanned downtime of your machine. Now, there is 3 different spline connection options available, which I want to show you. So option 1 is applying grease to the male-female spline connection. Longevity, however, in this option is limited, as any grease will break down over time, primarily dependent on the temperature within the spline connection. So therefore, this method requires re-greasing, and the intervals depend on the application and duty cycle. A better option is a wet spline connection, which consists of the shaft splines submerged into a bath of hydraulic oil. So typically here, technically speaking, we remove the shaft seal of the pump and reinforce the seal on the motor side to hold the additional pressure. And then we use the hydraulic oil that comes from the pump to lubricate the spline shaft. This is robust in many applications, and generally speaking, longevity is better, but maintenance may still be required, and its frequency depends on the application. So mounting position is also limited to horizontal mounting, as vertical orientation will not allow the case oil to reach the splines. So the best option available is Parker's patent-pending maintenance-free spline connection for lubrication, and it also eliminates any fretting corrosion in your application. So we can assure the highest longevity with that solution. In this solution, technically speaking, we create an oil flow to actively lubricate the spline connection. So the case oil is pulled through the rotating motor shaft by centrifugal forces created in the spinning shafts. This method can be used in horizontal as well as in vertical applications. Now, last but not least, let's think about our value chain. So do you prefer to buy individual components or integrated solutions? Even the best motor can only perform as good as the other components it is interfacing with. So we already spoke about considerations for connecting the motor to the pump, but also the cooling and the combination of the inverter and the motor needs to be well balanced. An inverter tuned to the motor's optimal performance will eliminate interface issues between the two components. Then Parker's configured e-pumps, which combine the hydraulic pump and the electric motor into a complete sub-assembly that can be ordered under one single part number, can also help to reduce supply chain complexity, logistics, and labor cost. Taking it even further, as you can see on the very right-hand side of this chart, experienced partners like Parker can also partner with our customers to provide completely engineered and bespoke subsystems like the ePTO subassembly that you can see here. So no matter which way you choose, selecting well-balanced components and your preferred level of integration will have a significant impact on your total cost of ownership. So then let's come to our final conclusions. What should you consider when selecting an electric motor? To recap, look for a comprehensive range that has the scalability, efficiency, performance, and reliability that you need for your applications. But also look at the ecosystem holistically. Electric motors that are connected to hydraulic pumps require special care. Electrifying hydraulics requires cross-technology experience and expertise. So an experienced partner like Parker can help you to avoid the pitfalls during your electrification journey. So that said, we are at the end of the breakout session. Thank you for your attention. We will now open it up for any questions. If you have questions, please enter them into the chat function. So you have the possibility to ask any questions. You just need to use the chat function here and enter them, and then my colleague Puno and myself will be happy to respond. If not, please, we will also share our email addresses with you, and feel free to shoot us an email after this session or connect with us on LinkedIn. Oh, there is a question coming in now. What's the use case for combining a variable pump with an electric motor?
I would say that the variable pump is very interesting to get high efficiency level. Speaking about the possibility to accelerate very quickly. That said, globally speaking, now we can use the variable speed as we presented, and I think it's even better than the variable displacement pump. It depends on each application, and it has to be considered depending on each customer specification. Hopefully, we've got on the Parker side the choice in between the different tech. Speaking about the pumps, we've got variable displacement, fixed displacement, even on different types of technology, such as a vane, gear, piston, etc. So there's no problem. we just have to get the specification, and then we can study it and discuss about it with you.
Thank you for the question. If there's no more questions, then we are just on time. Again, thank you. There is one more coming in. Are all the spline-mounted options released? Yes.
Yeah.
They are.
Yes, we've got the male splines for the traction applications and the female spline for the pump to get a pump direct mounting on the motor without any interface. So we've got globally the SAE A, B, or C. We've also got the SAE D for the biggest GVM. And we've got the ISO 3019/2 for some piston pumps either. So a wide choice of spline options.
You're welcome. So then we are on time. I will close this session now. Please go back to the main room, and thank you again for your attendance. If you have any further questions, we will be very happy to discuss in more detail. Please feel free to reach out to us via email or connect with us on LinkedIn. Thank you.
For your attention.
Bye-bye.